Bismillahirrahmanirrahim. Assalamu alaikum students. Now we are going to start the next method to find out the root, and that is the secant method. Students, let me tell you that this is a very simple method, and just like the Newton method, it also calculates the root of the equation. So what is the difference between the secant method and the Newton's method? Actually, first of all, let me tell you that since when we were talking about the Newton's method, we had to find out the derivative of the function. But in this case, we don't have to find out the derivative of the function. This is the first thing, and that is very important. Second thing is, from the name, it is quite clear and it is apparent that this includes the word secant. Secant means the line which touches the curve at 2 points. So it means somehow we are concerned with the 2 points on the curve. बेटा secant मेथड के हवाले से बात कर रहे हैं हम कि हमारे पास जो है वो secant मेथड, जैसे कि नाम से पता लग रहा है कि वो एक secant लाइन इसमें आएगी, और secant लाइन क्या है कि वो कर्व को 2 पॉइंट पे कट करती है. अब बेटा उस कर्व के 2 पॉइंट्स की बात करेंगे. इट मींस वी नीड टू चूज 2 इनिशियल गेसेस. In the case of Newton method, we had to choose 1 point, and then with respect to that particular point on the curve, we had to we had to draw the tangent line. और उसी tangent line के ऊपर आप कहते हैं कि आप you need to find a derivative. But in the case of secant method, you don't need to find out the derivative. Instead, you are just considering the 2 points on the curve, and then you are joining those two lines with a straight line, and then we simply proceed. So it means we are just concerned with the functional values, with the function value at 2 points. So students, this is the difference between the secant method and the Newton's method. Of course, we will proceed, inshallah. In the next slide, we will start drawing the curve and we will see how it works. But I'm just telling you, that's why I have just made this empty slide for you. So the reason is we can simply fill this white paper with these comments. So students, if you are considering the derivative, maybe if you are in the classroom, so you have very small questions and you are going to find out the derivative, so then maybe it's very easy to find the derivative. But sometimes it happens that the function is a very complex function, and complex doesn't mean that it has iota sign, but means complex, difficult question and a very tedious question, and you need to find out the derivative, and it's become very difficult for you to find out the derivative, and it takes a lot of time, and sometimes it happens that you are unable to find out the derivative. Number two, the second thing is that if you are using the programming on computer, then it takes a lot of memory to find out the derivative. So computational power is much needed for the Newton method because it involves the derivative. Whereas for the case of secant method, you don't need to have the derivative. So the computationally, we can simply say computationally, it is very less expensive. And also, since you don't need to find out the derivative of the function, so you just need the value of the function at different points, so it is quite easy. बेटा थोड़ा सा मैं फर्दर इसको एक्सप्लेन करता हूँ कि चूंकि हमारे पास अगर हम न्यूटन मेथड की बात करें तो आपके जहन में शायद ये बात होगी, यार डेरिवेटिव हमारा कौन सा निकालना इतना मुश्किल है, तो लिहाजा आप डेरिवेटिव तो फाइंड कर ही सकते हैं ना. लेकिन बेटा होता क्या है कि डेरिवेटिव जो है वो हमेशा डेरिवेटिव जो है वो आपको आसान फंक्शन का नहीं मिलता, बल्कि ऐसा होता है कि आपको डेरिवेटिव जो है बाज़ औक़ात ऐसे फंक्शन होते हैं जिनका डेरिवेटिव निकालना आपके लिए अच्छा खासा जो है वो मुश्किल हो जाता है. अब जब डेरिवेटिव निकालना आपके लिए अच्छा खासा मुश्किल हो गया, तो इसका मतलब ये हुआ बेटा, अब आपकी जो है वो एफर्ट जो है वो बढ़ गई, और जब आपकी एफर्ट बढ़ गई तो देन इट मीन्स कि और आपका इसका मतलब काम मुश्किल हो गया। इसके अलावा आपको ऐसा होता है बेटा कि आपको कंप्यूटर पे जब उसको सॉल्व करना पड़ता है, तो कंप्यूटर पे सॉल्व करते वक्त आपकी जो मेमोरी है वो बहुत ज्यादा यूज होती है जब आप डेरिवेटिव को यूज कर रहे होते हैं एक प्रोग्राम के अंदर, या आपको डेरिवेटिव फाइंड आउट करना पड़ जाए, तो दैट बिकम्स वेरी टफ, दैट बिकम्स वेरी टीडियस एज वेल। तो लिहाजा बेटा आपके पास क्या है सिचुएशन कि इस केस में जो सीकेंट मेथड है उसमें चूंकि डेरिवेटिव इन्वॉल्व ही नहीं है और जस्ट फंक्शन की वैल्यू फाइंड आउट आपने करनी है और उसी की वैल्यू आपने सब्स्टिट्यूट करते रहना है, तो इस तरीके से हम कह सकते हैं कि दिस बिकम्स वेरी सिंपल फॉर यू। तो बेटा आगे देखते हैं कि हाउ इट वर्क्स। स्टूडेंट्स, नाउ you can see the idea is very similar to the Newton's method। सिर्फ बेटा फर्क क्या है कि वहां पे आपके पास आप टेंजेंट लाइन ड्रॉ करते हैं, यहाँ पे टेंजेंट की बजाय आप सीकेंट लाइन यूज कर रहे हैं। So let's say we have a function, and of course I would again let you know that in the beginning you don't need to draw the graph, you don't need to draw the curve. So the main idea is that you just assume that uh, okay, there can be any curve. Of course, if there is a function, if there is a non-linear function, then there will be a curve. Of course there will be curve, and if that curve is intersecting the x-axis on the intersecting on the x-axis, then you can simply say that this is your root. So that point will be your, for example, here in this case you can see that this is your root value. So the main idea is that when you will start your approximation, so you must reach at this particular goal, so that you can say that okay, so this is your root, approximate root, because you are somehow converging to this particular point. So students, you can see that okay, so this is your actual root here, and I have already explained that your ultimate goal is that you need to find out the approximate root such that this approximate root is very close to this exact root. Okay, so students, what we do, you first of all you take the first initial guess, x naught. So this is your first initial guess, and basically this I am using the same figure actually which I used for the Newton's method, but then later on I will simply change the words as well, where I will simply write it here as the first initial guess, not the only initial guess, because we will use two initial guesses. So this is the point here. Let's say you can take any point, student. Now this is your now you can see that this is the first initial guess basically. So this point is corresponding to the on the curve. This is x naught, f of x naught, or simply x naught y naught. So this is the first point, first initial guess. You can choose any point, student. You know, you don't need to be worried about the positive value or the negative value of the function. No, you just need to find out any initial point. You don't need to check whether this gives you the positive value or the negative value. You just choose one initial guess, and then you choose another initial guess. See, student, here, so this x1, so this is the second initial guess here. So this corresponding to this point, this is x1 f of x1. So students, now there are 2 points. You can simply see that both points even are on the positive side. So both are giving you the positive value. Even if you take at this point, at this value, where my cursor is, this pointer is, so okay, maybe I think it's better if I change the color of the pointer, because I have already used the red sign, so I can simply choose the purple color maybe, or maybe this is not let me choose this, choose another, maybe green, but this is very small. I don't know why this is small. Oh sorry, laser pointer, I need to choose the laser pointer. So let's take the laser pointer to be purple color. Again, this is, I don't know, laser pointer is I guess only of red color. Okay, anyways, no problem. So students, here you can see that this is, if you take this point, so one may be positive and one may be negative, even then you will get the same idea, so no problem at all. But you don't need to be worried about the positive value or the negative value. So what you do is you can simply take any 2 points, whatever, whether they are both negative, whether they are both giving positive value, whether they are giving negative value, whether they one positive one negative, no problem at all. बेटा खास बात इसके अंदर इस मेथड के अंदर यही है कि आपको इस बात से परेशान नहीं होना कि जी आपको दोनों को एक पॉजिटिव लेनी है एक नेगेटिव लेना है, ऐसी वैल्यू जहां पे फंक्शन की वैल्यू पॉजिटिव आए नेगेटिव आए, या दोनों पॉजिटिव आए या दोनों नेगेटिव आए। नहीं बेटा, ऐसा कुछ आपने नहीं सोचना हो, ठीक है। मेन बात आपकी ये है कि आपने जस्ट 2 पॉइंट्स आपने ले लिए, वो कहीं पे भी हो, डजंट मैटर एट ऑल। और ये हमारे पास 2 पॉइंट्स हैं, x1 और x0 के ऊपर करस्पॉन्डिंग x1 f of x1 एंड x0 f of x0, या x0 y0 x1 y1। So now students, we just make a secant line. So you can see that this straight line crosses these 2 points. See, and students, this is important to note, and the idea is basically the same. This line cuts this x-axis at this point, so let's call this one a new point, and that is your next value. That is your next value, just like the Newton's method. In the case of Newton method, you had taken a tangent line and you were saying that the next point will be that point at which this tangent line touches the x-axis. But in this case, you can see and you can say that the next point will be that point at which this secant line touches the x-axis. I hope this is quite clear to all of you students. So students, so now this is the second point. Now just corresponding to this value, what will be the, so students, here just see the slide, this slide here. So this is x2 point here. What I have done here, so I made this secant line with x1 only in the case of secant method.